Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 2. In the last video, we have already discussed section 1, all questions from section 1, and today's lesson we will start from section 2, question number 11. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 11 says some animals use a pulse echo technique to collect information about their surroundings. Describe how this technique provides information about the surroundings. Pulse echo. It is very obvious from this name, means the name of this technique. It is given to us. This technique is pulse echo technique, and this is based on echolocation principle. So we can say this is based on echolocation principle. Now what is meaning of echolocation? Echo means that this is reflected sound. So when we say echo, it means we are talking about reflected sound, or you can say reflected pulse in this case, and this reflected sound will locate objects, mean the position of objects we can determine using echolocation technique. Mean animals, they use this technique. Let me explain you a little bit about this one. Imagine that this is a wall or this is any object. First of all, imagine that animal is located here. This animal will transmit a pulse. So this is the pulse. So this is pulse. This pulse will hit this object and it will reflect back. So now we will call this one is echo because this is reflected sound. An animal can detect the time between transmission of the pulse and receiving of the pulse, and based on that time it can determine the position of the object or location of the object. So this technique is pulse echo technique. You can also see here, in this case, this is our source. It will emit ultrasound waves. They will go this way and they will hit this and come back. There will be reflection. So if we have time taken, for example, just look at this one. Let's say if we have time taken between these two, let's say time taken is t. So this time taken is t. T to go to this and t to come back. So we can say again here. So this time from this animal to this boundary and this time from boundary to animal back. We can say this is t. And if the distance between these two, let's say distance is equal to t. So we can find out d distance. This will be equal to v, the speed of sound in this medium, times time taken, and this time has to be the half. So we have 2t, so we will be taking 1t, so we can find out the distance between animal and the wall. So very simple method. It has many uses. We use this technique echolocation in ultrasound, medical imaging, also it is used in sonar, and also it has many other applications. Let me show you the answer, how you can write on your answer. So this question has 3 marks, so you can mention these 3 points. First one, waves reflect off surrounding objects. So reflect off, so this is 1 point. Time to return is determined, means time when this pulse is emitted and the time when this pulse is received, that duration is determined, or you can say detected. And time taken then can be used to determine position of object, means d is equal to vt, position of object can be determined, and this is done by animal, in the head of animal. So animal can detect the time duration. Based on that they can figure out where object is located, and this technique is used by bat means the flying bats. And this question has 3 marks, so if you have written these 3 points you will get 3 marks. Question 12 says 2 resistors are connected in a circuit as shown in the figure. An expression for the combined resistance of 2 resistors is equal to this. we need to derive this expression. So first thing we need to understand, these two resistors are connected in parallel. So this is the first thing. Now if you look at this junction, current I is entering, so we can say current I1 is leaving and passing through this resistor, and here we can say this current is I2. Based on conservation of charge, so simply we can say based on conservation of charge, I has to be equal to, means the total current entering has to be equal to total current leaving the same junction, because charge is not used up. Energy is used up by components, but charge is not used up by components. And also we can connect voltmeter. Let's say we connect voltmeter across resistor 1 and reading on this one is V1, and we can also connect voltmeter across R2 and let's say reading on this one is V2. As they are connected in parallel, so simply we can say V has to be equal to V1 and V1 also has to be equal to V2. Now we can use Ohm's law, means this will be equal to potential difference across the component divided by resistance of that component. So we can find out value of current passing through that component. This is the potential difference across the component. So we can write on I will be equal to V divided by R total, and I1 will be equal to V1 divided by R1, and I2 will be equal to V2 divided by R2. As in this case, V1 is equal to V2 and they are equal to V. So simply we can write down V divided by R total. This will be equal to V times, means we can take V common. So we can write down here R1. Here we can write down this is R2. So on both sides we can cancel this V. So this V will be cancelled. So we left with 1 over R total. This will be equal to 1 over R1 plus 1 over R2. Now simply we can take LCM. So we can take this is R1 times R2. So here we will get this is R2 plus R1. We need to write on R total is equal to this one, mean the combined resistance. So the combined resistance, simply we need to flip this one. So we can write down R total in this case will be equal to the product of R1 and R2 divided by sum of R1 and R2. And this question has 3 marks. If you have written these points, you will get 3 marks. Question 13 says resistivity paper is paper covered with a thin layer of carbon. The distance between the ends of a piece of resistivity paper is 12.0 centimeters. The resistivity paper is 4.2 centimeters wide as shown in the figure. The resistance between the ends of the resistivity paper is 8.8 centimeters. Calculate the thickness of the layer of carbon. Resistivity of carbon is given to us. We need to find out the resistance between these two ends. So simply we can imagine our battery is connected between these two ends. Now we need to understand resistance is equal to rho L by A. And this is the cross-sectional area we need to consider because current is entering from this side. And so we can say cross-sectional area in this case will be equal to W, the width means that is equal to 4.2 centimeters times the thickness. Now we can rearrange, we can say thickness in this case will be equal to rho L divided by R times W. So we have value of resistivity that is 3.7 times 10 to minus 5, and we have to consider this L, so this is 12.0 times 10 to minus 2 centimeters. We have to convert into meters, and value of R is given, that is 8.8 ohms, and the value of W we have, that is 4.2 times 10 to minus 2. Now simply we need to solve this one. If we solve this, means if we calculate value of T, we will get that is equal to 1.2 times 10 to minus 5 meters. So this is the thickness, mean this thickness we have figured out. So there are few points you need to understand: which L you have to take when you use the formula, and which area, cross-sectional area, you have to consider. Cross-sectional area through which current is entering or current is leaving. Next time if they ask you to calculate resistance between these two sides, So you will be taking this cross-sectional area, this will be the L. So these things you need to understand, what L is representing in this equation and what A is representing in this equation. So if you have got this right answer and you have used this formula, if you have used this formula, you will get 1 mark, and the second mark you will get if you have used A is equal to W times T, and the third mark you will get if you have got the right answer. Part B says a student connected the ends of the resistivity paper to a cell of EMF 1.5 volts and a voltmeter as shown in the figure. The reading on the voltmeter is 1.4 volts. Calculate the internal resistance of the cell. So this reading is given to us. So this is equal to 1.4 volts. It also means that PD across the terminals of the cell, we can also imagine, first of all, this is the internal resistance. So we can draw, this is over cell. So this one is over cell. So the PD across terminals of this cell is also equal to 1.4 volts. So if we connect our voltmeter across terminals of this cell, the reading on this one has to be equal to 1.4 volts. And EMF of this one is 1.5 volts. It means 0.1 volts is wasted here. So we can say EMF in this case, it has to be equal to VR plus, we can say resistance of this one is capital R, has to be equal to V capital R. So we have EMF in this case 1.5 volts, and this one we can find out because this value we have, that is 1.4. So the potential difference across the internal resistance, that is equal to, so we have PD across internal resistance. Now we can find out value of current because we have resistance of this resistor that was equal to 8.8 ohms. So we can find out value of current, that will be equal to V divided by R, means 1.4 divided by 8.8. we will get this is equal to 0.16 amps. So current passing through this resistor, this current is equal to 0.16 amps. This is ideal voltmeter, so no current is passing through this one, very little, so we can ignore. So current here in this branch, that also has to be equal to 0.16. so current passing through this internal resistor is also equal to 0.16. so now we can write down VR, this has to be equal to I times small r. We need to find out internal resistance, so this will be equal to VR divided by I. So we have value of V, that is 0.1 volts, and this is divided by current, that is 0.16 amps, and if we simplify this one, we will get 0.63 ohms. So this is the internal resistance, 0.63 ohms. So this is how you can figure out, a very beautiful way to figure out this type of problem. So this is very important one. So first thing you need to understand is this. You can find out value of VR, then we can find value of current because no current is passing through this one. Resistance of ideal voltmeter is close to infinity. So for ideal purposes, we can consider this one. Resistance is infinite. So this is how you can figure out. Second part says the connection to the right hand terminal of the voltmeter was moved to a distance of 3.0 centimeters from the left hand side of the resistivity paper. Determine the reading of the voltmeter. So first of all, let's try to understand what is given to us, what this question is telling us. It is given to us, first of all, voltmeter is connected here, the right hand terminal of the voltmeter. Then we move this right hand terminal from here to this point. So right hand terminal is here, and the length of this part of resistivity paper we have, that is 3 centimeters. And question is asking us what is the reading on this voltmeter. We can also imagine if we connect a voltmeter between this point and this point at 3 centimeters. So let's say we connect voltmeter V1. Reading on V1 and reading on this voltmeter will be the same. And also for this question, we have already figured out that the potential difference across this resistivity paper, that is equal to 1.4 volts. So this is equal to 1.4 volts, because this is equal to the terminal potential difference across this cell. So we have reading of V2, this reading we have, and the total length of this resistivity paper is equal to 12 centimeters. Now when we are talking about the same resistivity paper, so let's say current I is coming, current passing through 3 centimeters and 9 centimeters is the same, because this is the same resistivity paper. So from here we can say current passing through 3 centimeters is the same as current passing through this whole resistivity paper, 12 centimeters. So this is first thing we need to understand. Now how we can find out value of current passing through 3 centimeters? We can say this will be equal to potential difference across this one divided by its own resistance, that will be equal to rho L by A, and the total PD across this resistivity paper, that is equal to 1.4 volts, and divided by the total resistance of this resistivity paper. We can say this is rho L by A. We can also say, let's say this is L1, we can say this is L2, so we can say this is A2, we can say this is A1, and resistivity in this case, this is resistivity. If you want to write on, you can say this is rho 1, this is rho 2. As we are talking about the same resistivity paper, it means it is made of the same material, so this resistivity will be cancelled with this one. And cross-sectional area, because it has uniform cross-sectional area, so this also will be cancelled. So we left with V1 divided by L1. So L1 is 3 centimeters, so we can say L1 is 3 centimeters, and here we have 1.4 volts, and here we have this is 12 centimeters. We need to find in this case V1, so we can say V1 will be equal to 3 centimeters times, this is 1.4 volts, we have 1.4 volts, and this is divided by 12 centimeters. You no need to convert units because centimeter will be cancelled, so this is also centimeter. So we will get V1 is equal to 0.35 volts. So this is a proper way to answer this question. It's a nice question. This question has only 1 mark, but it's a conceptual question. Many students, they will get stuck with this question if the basic concepts are not clear. So this is a way to answer this question. So the main concept is this one. Current passing through 3 centimeters and 12 centimeter resistivity paper is the same. And then we can simply use Ohm's law and we can figure out answer. Question 14 part A says, deduce whether the circuit would switch on the heater when the temperature falls below 10 degrees Celsius. You should include a calculation of the PD across the thermistor when the temperature is 10 degrees Celsius. So we need to calculate PD across this thermistor. So first of all, we can simply imagine we have a voltmeter that is connected across this thermistor. In order to calculate this PD, we need the resistance of this thermistor, and resistance of the thermistor we can simply read from here when the temperature is 10 degrees Celsius. So we have 0, 1, 2, 3, 4, 5. So this is 10 degrees Celsius. At 10 degrees Celsius, we can read value of resistance. So this is 2 ohms. So the resistance of this thermistor is 2 ohms. So we can say resistance of thermistor, this is equal to 2.0 ohms. Now we need to find out the PD across this one. As this resistor 15 ohms and thermistor, they are connected in series, it means current passing through thermistor is the same as current passing through these two together, means 15 ohms plus we can say 2.0 ohms mean thermistor. This is the total current. Total current is equal to the current passing through this thermistor, because current passing through the switch is negligible. We are assuming its resistance is very high. As current is the same, so we can say PD across thermistor, simply you can say V1 divided by the resistance of thermistor, that is equal to 2.0. Total PD means the total PD across this one and this one, that is equal to 6.0 volts, and the total resistance of these two resistors in series we have 15 plus we have 2.0. So from here we can find out value of V1. V1 in this case will be equal to 0.706 volts. 0.706 volts. As this value is greater than 0.70, it simply means that heater will be on. As temperature go down further than 10 degrees Celsius, resistance will increase. Mean this value will increase. So this resistance will increase. As this resistance increase, it means this V also will increase. V will also increase. So simply we can say as temperature goes below 10 degrees Celsius, as the temperature will decrease, the resistance of thermistor will increase. As resistance of thermistor increases, PD across thermistor, this one will also increase. So heater will be on. So we can simply say heater will be on. So this is how you can answer. So heater will be on when temperature falls below 10 degrees Celsius, because heater will be on at this when temperature is 10 degrees Celsius. Then if temperature even drop than 10 degrees Celsius, resistance will increase. As resistance will increase, it means there will be higher PD across thermistor, so heater will be on. So this is how you can answer. This is just based on the previous concept. If you have mastered this concept now, a lot of questions, mean the tricky questions based on this concept, you will be able to answer. Part B says explain why the resistance of the thermistor changes with temperature. In order to answer this question, we need to understand what kind of material we use to make thermistor. Thermistor is made from semiconducting material, means is a semiconductor, is kind of semiconductor. As it is kind of semiconductor, when we increase the temperature of this one, electrons will gain energy and the number of free electrons will increase. So the number of free electrons will increase. As number of free electrons increases, or you can say number of conduction electrons increases, means more electrons in the conduction band. It means that resistance of thermistor will change. In this case, resistance will decrease, and vice versa is also true. So these are the points you need to understand. This question has only 2 marks, so you can mention 2 points. You can say as temperature increase, more free electrons. As there are more free electrons, it means that resistance will decrease. So these 2 points you have to mention in your answer, because this question has 2 marks. So this is how you can write on your answer. If you have written the first point, you will get 1 mark, and if you have written the second one, you will get 2 marks. But the second one is depending on the first statement. If you have written this one and then you have written this, you will get 2 marks. That's all for today's lesson. We will stop over today's lesson here, and I'll be uploading the remaining questions very soon before your exam. If this video was helpful, please like and subscribe, and also leave some comments in comment section as always you do. In order to support this channel and also for extra resources, please join Patreon.